Okay, chapter 3, complex tree, example 8. Okay, in this example, your job is to sketch two loci given by the given expression here. Okay, so simple instruction is always double confirm what you have been given, are they in the standard form. So this looks very similar to something of your perpendicular bisector, but it's not in the standard form yet. Similarly, this looks like a circle, but you need some adjustment to make it into the standard form. So once you write it into the standard form down here, these two are your standard forms. Okay, you can see very clearly this is a perpendicular bisector of the line segment joining -1, 0 and 0, 1. And then this is a circle centered at -3, 3, radius of 2. Okay, so in this solution, in this lecture example, everything has been pre-drawn for you. My advice to you is try doing it on your own. Try drawing it. Okay, the rules to follow, let me repeat again. Make sure you have equal scaling on your real and imaginary axis. Use a compass, use a protractor to draw your circle, draw your half line, etc., etc. Okay, so what you should have generated from here, of course, circle. Okay, so what you must indicate again, reminder, center of the circle must be given as -3, 3. Radius of the circle must be indicated. Then the other one is a perpendicular bisector. Draw in your 2 points. Okay, give me the 90 degree, give me the equidistance. These are the few marking points, and that's how you actually earn your 5 marks. Okay, thereafter, important thing, make sure that your circle, if it's not supposed to hit the origin, it doesn't hit the origin. Your perpendicular bisector is supposed to hit the origin, it must pass through the origin. Okay, so this is your first 5 marks. Thereafter, question asks you, find the complex number in your Cartesian form, okay, a plus ib form, of the intersection of your two locus. I need to find the intersection of the two locus. Basically, I need to find this point and this point. So a few methods you have, okay, either trigo, or you can use your so-called Cartesian, change into your x and y equation, solve it using circle and an equation of a straight line. So again, my focus is on trigo. Okay, so when you want to activate trigo, focus on radius of circle, focus on center of circle, focus on the equation or the two coordinates. Okay, these two coordinates of a half line and of course the midpoint. So what you have, I'm zooming in down here. Okay, you're supposed to find this point and this point. Okay, then you know the radius of the circle is supposed to be 2. You know this point is -3, 3. Okay, so very simply, you can actually sort of infer that phi is equals to pi over 4. Okay, phi is supposed to be equals to pi over 4. And then from there, x is equals to, using your trigo relationship, x is 2 cosine pi over 4, y is 2 sine pi over 4. So again, you may ask me, how do I infer this? Okay, the inference comes from your perpendicular bisector. Okay, the perpendicular bisector is a line segment that passes through -1 and 1. And coincidentally, this line segment also passes through -3, 3. So technically, this equation of the line is y equals to -x. Okay, equation of this line is y equals to -x. And the gradient is 45 degree or pi over 4. And that's how I make this inference. Okay, then of course your trigo to get your x and y coordinate. And thereafter, taking reference from the center of the circle, x units to the left of -3, so it's -3 minus √2 will give me my x-intercept. Then 3 plus y, which is 3 plus √2 I. So these will be my coordinates, or in Cartesian form, of the complex number representing point A. Similarly, you can find the Cartesian equation, the coordinates or the complex number representing point B.